Welcome back, guys, to our level up series. Let us look at today's question. The question is minimum cost to reach destination and time. The question is a bit lengthy, so I will try to explain you the question in short. What does the question says? We are given with these nodes, which are supposed as cities in this particular question. Suppose these all nodes are the cities. The edges connecting them represents the time which it takes to travel from city 0 to city 1 to city 2, and so on. And which is written in blue color, that is the amount of cost that you need to spend while passing from that particular city. That is the passing fees. The cost of your journey is the summation of passing fees. So there is a passing fees associated with each and every city. So the basic idea is these nodes are these cities. The edges connecting them denotes the time which is required to travel from one city to the another city. And the one which is written in blue color is the passing fees that we need to pay when we go from when we pass from any of the city. So this is the basic idea. What does the question says? We need to return the minimum cost if we want to complete the journey from node 0 to node n minus 1. So see, here node 0 is there, here node 5 is there. So we need to return the journey from node 0 to node 5, which requires the minimum cost. But there is one more condition. We are also given with one variable max time, and the we need to go from city 0 to city n minus 1, that is city 0 to city 5 in the minimum cost, but the time should not exceed this max time variable. Now the question will be clear to you much more. Let me explain. Let me tell you in short. If I want to go from city 0 to city 5, suppose I have three options. First option is I can go from city 0 to city 5 in 25 minutes, but the amount of cost is $100. Second option is I can go from city 0 to city 5 in 30 minutes, but the amount of cost is lesser than the previous one. Before it was $100. Suppose it is $50 in this case. And third is I can go from city 0 to city 5 in 35 minutes, suppose, but the amount of cost becomes more or less, suppose $25. But in the question, it is said to us that our journey should not exceed 30 minutes. So we will go with the option number 2. That is, we will try to minimize the cost without exceeding the maximum time. It means we will avoid the journey for 25 minutes. We will go with 30 minutes because the amount of cost is less. So the question is, we need to return the minimum cost to complete the journey. And if we are not able to complete the journey with the maximum time, then we need to return -1 in this particular case. What we are given the max time such that our journey should not exceed it. We are given with the edges. We are given with the passing fees, which is associated with each and every node. So this is the thing. And the cost of the journey is the summation of the passing fees for each city that we pass through at some moment of our journey, including the source and the destination city. Now let us understand this question with the help of this example. These cities are numbered from 0 to 5. The times are also given in the form of the edges, and the passing fees is given in the form of a blue color. The maximum time is 30. We need to go from 0 to 5. There are two options. The very first option is we can go 0 to 1, 1 to 2, 2 to 5. What is the amount of time required? 10 plus 10, 20, 20 plus 10, 10, 30. The second option is we can go from 0 to 3, 3 to 4, 4 to 5. What is the time required? 1 plus 10, 11. 11 plus 15 is 26. This journey requires 26 minutes. This requires 30 minutes. This is requiring less time. So if it is asking about only about time, we would have directly written this using the Dijkstra's algorithm. But here is a twist. We have to minimize the cost, keeping max time in our mind. So both of them do not exceed the max time. One is 30, one is 26. The max time allowed is 30. So both are not exceeding the max time. So now we want to minimize the cost. So the one which requires less cost will be our answer. So let us see how much cost is required for this one. It is 5 plus 1, 6 plus 2, 7 plus 3, 10. $10 are required. In the second one, 5 plus 20, 25. 25 plus 20, 45. 45 plus 3 is 48. $48 are required. So which is requiring the less amount? This $11. 5 plus 1, 6. 6 plus 2, 8. 8 plus 3, 11. So we are going to return 11 in this particular case. We will consider all the journeys from node 0 to node n minus 1, which is under or equal to the max time. Among all those journeys, we will see which is requiring the minimum cost, and we are going to return that particular cost. See in example number 2. We need to go from 0 to 5. Again, two paths are there, 0 to 1, 1 to 2, 2 to 5. It requires 30 minutes. 0 to 3, 3 to 4, 4 to 5. This requires 1 plus 10, 11. 11 plus 15 is 26 minutes. The max time allowed is 29. So now we cannot consider this particular path as it is requiring 30 minutes. So we are directly going to omit it. There is only one path which is requiring 26 minutes. So we'll calculate its cost, which comes out to be 5 plus 20, 25. 25 plus 20, 45. 45 plus 3, 48. And we are going to return this particular cost. So I hope the question is now very much clear to all of you who are watching this particular video. Now let us look at its approach. Whenever minimum cost is asked, the thing comes to our mind is Dijkstra's algorithm. So here also we are going to apply the Dijkstra's, but with some of the modifications, as there are some more things given to us that it should not exceed maximum time, and we need to minimize the cost in this particular case. We need not to minimize the time, we need to minimize the cost. So this is the main thing. So what I am going to do, let's see. First of all, the main thing is some people can get confused in this thing also. We are not provided in the question, we are only provided max time, edges, and the passing fees. We are not provided how many number of nodes are there in this particular case. It means how many number of cities are there. So we know each city has a passing fees. So we will calculate the size of the passing fees vector. Int size equals to passing fees dot size, and this size will be equal to the number of cities present in our graph. I hope it is clear. So this can be a bit tricky for someone who has not practiced much. So I have made it clear to you all. So this size is the denotes the number of cities also. The int size one, we have stored the edges dot size. Now we have run the loop and we have created the adjacency list, which we do in each and every graph question. After that, we have created one min heap for the Dijkstra's algorithm. In our min heap, we have maintained two pairs. First one is the main pair that we are going to store three things in our priority. The very first thing is going to be the time which is taking. The second one is going to be the city, at which city we are located at present. And the third one is going to be the cost. So we are going to start from 0, city 0. So, and initially, if we are starting from city 0, the distance also required is 0 only. So we have passed 0. Initially, we are starting from city 0. That is why here also 0. And what is the initial cost? The passing fees of 0th index. So that is why passing fees at the index of 0. We have maintained one cost array to store the cost, which is required for minimum cost, which is required to travel to that particular city within the constraint of this max time. While not equal to pq.empty, first one is denoting the time. Assume it as distance only, as in most of the question we take it as distance. So I have taken it as distance only for much clarity. In distances equals to pq.top.first. In node equals to pq.top.second.first. And in the third one is the costing. Then I have popped it out. If cost at the index of node is lesser than or equal to cost, what does it say? This condition means if I am already reaching node 2 in a much better cost than at present, then I need not to go further. I will directly use the jump statement, that is continue. Otherwise, if costing is greater than cost at the index of size minus 1, what does it mean? It means if costing is greater than cost at the index of size minus 1, at the end, I need the cost at the index of size minus 1 only. Cost at the index of size minus 1 means destination node cost. So if I am reaching my destination node in a much better cost than this present cost, then also I can use the jump statement continue. I need not to continue further. If distances is greater than max time, what does it mean? It means if distances is greater than max time, if it means that it is taking much more time, which is greater than the constraint provided to me in the question. So then also I need not to go further because I cannot consider it. I will again use the jump statement continue. If distances is less than or equal to max time, I will update my cost array. That is cost at the index of node equals to min of cost at the index of node comma costing. It will take the minimum value amongst these two. And then I have made one vector to iterate through all its adjacent cities. So for int k equals to 0, k less than v1 dot side k plus plus. This is the new distance which it will require to travel to that particular city, and this is the new cost that particular cost which is given the priority queue plus the passing fees of that particular city. If new costing is lesser than cost at the index of size minus 1, it means if I am able to reach my destination city in a much better cost, then this condition will become true. As well as it is following the constraint, that is new distance is lesser than or equal to max time, as well as the new costing is lesser than cost at the index of v1 at the index of k dot first. It means if I'm at node 2 and I am this is also making me reach to node 2 only, but it is making me reach in a much better cost. So this condition will be. If all these conditions are true, I will push it to my priority queue and it will keep on continuing. Once this loop gets completed, if my destination city cost is int max, which I have initialized it initially, it means I cannot reach to my destination city in a constraint provided to me. So I'm directly going to return -1. Otherwise, I am going to return the cost of my destination city, which is my answer. So I hope the question is clear to you all. The question was uh, not much tougher. It is just a modification of Dijkstra's algorithm. If you have practiced Dijkstra in a better way, you will be able to solve this question. And I hope I was able to explain you this question in a better way and you all would have understood it. If you all would have understood the question, don't forget to subscribe to the channel and share it with your friends. We will meet up in another video. Till then, goodbye and keep coding. Thank you.